Welcome to Quality Branding Hub. The channel is for the quality control engineer, site engineer and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also I am going to discuss about a very important topics about the concrete, rather the mixed design, that is a moisture correction of the RMC or the moisture correction of the concrete. So in today's video I will discuss what is moisture correction, why it is important and how to do the moisture correction and why moisture correction is extremely important. So it's today's video I will discuss each and everything, so stay tuned until then to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification. So let's jump into the subject, that is moisture correction. Now that terms is moisture correction, that means moisture which is nothing but water. The correction means correction, that means you need to adjust the moisture into the mix. Now what is in the mixed design? In the mixed design we are finding the mixed proportion, that is cement, sand, coarse aggregate, water, admixture and everything. Now the coarse aggregate and the fine aggregate has that property that they are retaining the moisture. Now if they are retaining the moisture, whenever we are adding water into the mix, that means this moisture can release to the mix and the water cement ratio will increase. And if the water cement ratio is increased, what will happen? We will not get the desired strength. Our strength and durability will be in a problem. So this moisture has to calculate. Otherwise our whatever the mix proportion we have already decided, that mix proportion will not be the same one. So that is why it is extremely important to adjust the moisture correction. Why? Because we cannot get the coarse aggregate and fine aggregate exactly in the dry condition. Now according to that, if we are not getting the dry condition, that means there are some percentage of the water into the mix and this water will contribute to the water cement ratio of the mix. Now water cement ratio is extremely important. Why? Because this water cement ratio is determine what will be the concrete strength, concrete durability and everything. If the water cement ratio is increases, the strength will be decreases, workability will be a problem. So that is why we need to maintain whatever the moisture water cement ratio we have made. So what is water cement ratio, what is the factor effective, how to choose the water cement ratio, I have made a detailed video, link is there or in the description, please check, you will get the full information. Now to start with what is moisture correction, that before that we need to know what is the structure of the aggregate, be it the coarse aggregate or the fine aggregate. So in the aggregate there are surface and also there are some internal pores into the aggregate. Now whatever the moisture is coming, that moisture can be inside the pores or in the surface or in the both. Depending upon that, there are four certain condition is there. That is, one is moist condition. In the moist condition, what is happening? The pores inside the aggregate is filled and the surface is also filled with the water. And in this condition, whatever the moisture is there, that moisture will be released to the mix whenever we are adding water or in the mix. So this extra water will be a problem for the concrete. Now what to do? What is happening? This moisture is contributing into the mix, that means water cement ratio is increasing. So we are not getting the strength or the durability, whatever the requirement. So this condition is called the moist condition. Another condition is called, now this moist, and if you start hitting that one, what will happen? The first is whatever into the water into the surface, that will evaporate, but still the water inside the pores will be there. In this condition is called surface saturation dry condition. That means surface is dry, surface is saturated, but the inside pores are filled with water. In this condition, what is happening? If we are adding water to the mix, neither it is taking the water from the mix or it is contributing. So this is the ideal condition, but practically it is impossible. We cannot deliver or we cannot get the coarse aggregate or the fine aggregate in this condition or the surface saturation dry condition. In the surface saturation dry condition, the surface is dry, but the internal pores are filled with water. But in the moist condition, the internal pores and the surface both are filled with the water. Now, if you still heating, now the next condition is, that is the air dry condition. So, if you continue dry one, that means surface is completely dry and in the internal pores may contain some waters, may or may not may contain some water. This condition is called the air dry condition. And the fourth category is oven dry condition. That means it is completely dry. That means it is neither in the surface nor in the internal pores there is no water or there is no moisture. This is called the oven dry condition. So, there are four conditions, that is a moist condition, that is a surface saturation dry condition, air dry condition and the oven dry condition. Now, what is happening, maximum case whatever the mix design we are doing in mix design as per the SSD condition. That means we are assuming that there will be no water to be added or water can be contributed or can be absorbed from the mix. What is happening if you are adding the oven dry aggregate into the mix? So, whenever the water will added into the mix, the water from the mix will absorbed by the coarse aggregate and the fine aggregate. So, that time the total water in the mix will be less, but in the moist condition it will release, the total water will be more. In the both the conditions it is harmful and we will not get the desired strain as per the requirement. So, that is why both the condition is not harmful, but in practical and the reality what the moisture we are getting, that is what the coarse aggregate we are getting, that is in the moist condition. That means there are some percentage of water into the mix. Now, suppose we have getting the coarse aggregate quantity 800 kgs per cubic meter or 1200 kgs per cubic meter. Now, in the moist condition, if we take the 1200 kg, we are not getting the exact 1200 kgs because in that 1200 kg there are some wet water. So, we are getting the less amount of coarse aggregate and more amount of the water. So, the mix ratio will be a problem. Same for the fine aggregate also. Suppose it is 800 kgs and if we are taking 800 kgs, there are some percentage of the water into the mix. So, what is happening? The fine aggregate quantity will be the less than 800 and the total quantity of water will be the more as per the requirement. So, we are not getting whatever the desired, whatever the our mix proportion, and if we are not correcting the moisture as per the requirement, that will be a harmful and will be disaster for us. So, we need to calculate the moisture correction. Now, how we can calculate the moisture correction? And that is as code is given, take the sample, take the oven dry, take the weight, again then take the weight and then you can find out what is the moisture percentage or percentage. Suppose you are getting the moisture percentage in a certain day, the 4% is coarse fine aggregate and 1.5% is coarse aggregate. Now, you need to calculate how it can be into the mix and how it can be the our final mix proportion calculating the moisture correction. So, here I have an example, I can take this one. In this example, I have cement is equal to 332 kgs, fly ash 142 kgs, water 165 kgs, coarse aggregate in SSD condition 1069 kgs, fire aggregate 719 kgs, admixture 4.74, water cement ratio 0.327. Now, whenever I am calculating the water percentage or the moisture percentage into the mix, I found in the 4% for the coarse fine aggregate and 1.5% for the coarse aggregate. Now, what is my fine aggregate percentage? That is 719. Now, if this 719 is not the only sand, it is sand plus moisture is equal to 719. But what is the percentage of moisture? That is 4%. So, what will be the sand quantity to take the 719 kgs? To get the 719 kgs of sand or the fine aggregate, how much will be the total quantity? Because the moisture is there, the 4%. So, 1 plus 4, now that is 1.4%, that will be 719 into 1 plus 4 that percentage, that will become 748 kgs. Yeah, it's coming 748 kgs. So if we are taking 748 kgs, we are getting 719 kgs sand, and 748 minus 719, that is coming around 29 kgs, 29 kgs of water. So to keep our mixed proportion same, according to the 719 kgs, we need to take the 748 kgs of sand in terms of to getting the 719 kgs sand into the mix, and remaining 29 kgs, that is the water. So these 29 kgs will be added into the water, into the mix, and for the coarse aggregate my quantity is 1069, and what is my percentage is 1.5 percentage of moisture it can retain. Now to get 1069, if I take only 1069, we will not get, we will get the lower percentage of the lower amount of the coarse aggregate. So again 1.5% we need to add, and if we add that one, it is coming 1065 kgs. 1085 kgs. So 1085 kgs, if we are taking coarse aggregate, then we will getting 1069 kgs of coarse aggregate in terms of as per our mixed proportion of the concrete. But 1085 minus 1069, this 16 kgs is, what is this? That is moisture, and that will be added into the mix. So from the fine aggregate we are getting 29 kgs, from the coarse aggregate we are getting 16 kgs. So total how much we are getting? 29 plus 16, that is 45 kgs. Now what is my total water into the mix? That is 65 kgs. Now we are getting 165 kgs, 155 kgs. So from these 155 kgs, we need to deduct the percentage of water what we are getting from the coarse aggregate and fine aggregate, that is for that 45 kgs. So if we are deducting that one, so what will be the percentage? That will be the percentage 332 kgs, 142 is cement, but the coarse aggregate will be 1085 and the fine aggregate will be 748 kgs, and water will be 155 minus 45, that is 110 kgs, but the water cement ratio will be the same. So in this way you can calculate the, or you can take the moisture correction whenever you are doing any kind of work or any kind of RCC work. So you need to first find out what is the moisture percentage, then you need to find out then total percentage of moisture present in the coarse aggregate and the fine aggregate, then whatever the coarse aggregate quantity you have to multiply, and you have to find out the exact quantity, and then you have to find out what will be the water percentage, what water will be contributed by the coarse aggregate and the fine aggregate, and accordingly you have to minus the water percentage and plus the coarse and fine aggregate percentage, and in this way you can find out the revised mixed proportion, and that will be your the proportion as per the design. Otherwise if you are using the same mixed proportion without correcting the moisture, then it will be not as per the requirement, or you will not get the stain. So these are all about this today for the moisture correction of the concrete, and I hope you find it useful, and if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video you will get immediate notification, and I am waiting for your valuable comments, so that from your valuable comment everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this, and thank you once again for watching me.